Hello, 8th grade. Today we're going to talk about parallel and perpendicular lines. And our objective today, by the end of this lesson, you should be able to write an equation of a line that passes through a given point and is either parallel or perpendicular. Ooh, spelling is bad today. To that given line, okay? So we want to write equations of lines that are parallel or perpendicular. So you'll remember that we know how to write lines based on a few things. We can write an equation of a line in y equals mx plus b form if they give us the slope in the y-intercept, the slope in one point, or if they give us 2 points, because we can use those 2 points to find the slope and then kind of go back to this middle idea. And if they give us a slope and a point, that's kind of what we're doing today with parallel and perpendicular lines, is they'll give us a point, like we said over here in our objective, and they'll also give us not necessarily what the slope of our line is, but what the slope of a different line is, and we can adapt that for our line that we're going to write. Okay? So, first of all, we have to talk about a couple rules. And I know rules are like not so much fun. But let's talk about rules for parallel lines first. And the abbreviation for parallel, so you don't have to keep writing it, is these two kind of diagonal lines next to each other. Okay? So let's talk about the rules for parallel lines. The first rule is that all horizontal lines are parallel to each other and to the x-axis. That may seem kind of obvious that all horizontal lines are parallel to each other. Then obviously it can be said that all vertical lines are parallel to each other and to the y-axis. And our third rule for parallel lines is that if two non-vertical lines in a plane, because lines exist in a plane, if these two non-vertical lines in a plane have the same slope, then they are parallel. And it does have to be non-vertical because remember, vertical lines have what kind of slope? Good, they have no slope. If I come to the edge of a cliff while I'm skiing, I should say no because that has no slope. So let's give examples of parallel lines. And remember, if they are parallel, they have to have the same slope, that same m value. So I'm going to start out with a given line, y equals 2x plus 4. Okay? And this is in y equals mx plus b. And we know that m is my slope, so my slope here is, good, 2. So I'm going to look at this, and I'm going to say a parallel line would have the same slope. So I might pick a line that is 2x plus 2. And I can say that's parallel because it has that same slope. I could even get so crazy as to say 2x minus 1,000 or 10,000 or bigger. But as long as it has that 2 where the m is supposed to be, we know that it has the same slope and that it will be parallel. So go ahead and give me a line that is parallel to my original line, 2x plus 4. Okay, so give me a line that is parallel to that line. And like we have rules for parallel lines, we also have rules for perpendicular. And the abbreviation for perpendicular is this, like upside down T, because we can see it makes a right angle, like perpendicular lines form a right angle. And the rule here is that 2 lines are perpendicular if their slopes multiply together to form -1. Okay? So let's look at some examples to see what I actually mean by this. So I'm going to start with that same line, y equals 2x plus 4. And to write a line that's perpendicular, I need something times 2, because that was my slope of this line, to multiply to equal -1. Well, I know to equal +1, I would multiply by the reciprocal. So I'm always, to equal -1, I'm going to multiply by the negative reciprocal. Okay? And the negative reciprocal of 2 is, good, it's -1/2. So this -1/2 is going to be my slope of the perpendicular line. And again, I can write any equation that has the slope -1/2, and that is perpendicular to my original line. Okay? So, why don't you guys take the line y equals 1/6x plus 3 and come up with a line that is perpendicular to that. Perpendicular. Okay, so your line should have had the slope -6, because that would be the negative reciprocal, and then -6x plus some b. And you can use the same b, you can use that 3. You can use any b as long as your slope looks like the negative reciprocal in order to form a perpendicular line. Okay? Let's try one more of the perpendicular, because sometimes they're a little hard to get. So we'll try y equals 3/2 x minus 6. So I'm looking for a line perpendicular to this. And it should have a slope of -2/3, because that's the negative reciprocal, and then plus whatever b value you want. Okay? So, that's all well and nice, but we need to, I don't know, get a little harder, a little more challenging. Okay? And if we remember from our objective, we said that we are going to write a line that passes through a given point parallel or perpendicular to a given line. So let's go ahead and we'll start with a line, y equals 1/2 x minus 3. And I want to write the equation of a line that is parallel line, and it passes through the point -1, 2. So the first thing we know about parallel lines is that any line is parallel if it has the same what? Good, slope. So I'm going to start with that same slope, y equals 1/2 x plus some b. And I'm going to say plus b. I'm not going to make up a b right now because I'm looking for it to pass through this point. So if you remember way back from a couple days ago, when we did writing an equation of in slope-intercept form part 1, we did this exact thing, and we're going to plug this point in as our x and y values. So I'm going to plug in 2 equals 1/2 times -1 plus b, and I'm going to solve for b. Add the 1/2 to the other side. So b equals 2.5. And then I would write my formula, y equals 1/2 x plus 2.5. And if you want to make that an improper fraction, be my guest. Okay? So that's how we would do one if it's parallel. Okay? If it's perpendicular, let's say we start with that, or something very similar, -1/2 x minus 4, and I want a perpendicular line that passes through -2, 3. Okay? So I know for a perpendicular line, I'm going to take the negative reciprocal of -1/2, which would be +2, because that would multiply to -1. So I'm going to start with y equals 2x plus b, and I'm going to plug in that point. So I have 3 equals 2 times -2 plus b. If I add 4 to both sides, I get that b equals 7. And I have my equation that's y equals 2x plus 7. Let's go ahead and try some examples on our own. So first of all, I have a line that's y equals -2x. And I want it to be parallel and pass through the point 0, 3. So see if we can come up with a line that passes through 0, 3 and is parallel to my line y equals -2x. Well, we know that parallel lines have the same slope, so we start with y equals -2x plus b, and we plug in these values for x and y. So I say y equals 3 times -2 equals -2 times 0 plus b. Obviously this becomes 0 and drops out. So b equals 3. So my final equation would be y equals -2x plus 3. Okay? One more. I have an equation that is y equals -3/5 x plus 2. And I want a line that is perpendicular and passes through the point 0, 2. Okay, so try this one on your own. Okay, so perpendicular lines, I take the negative reciprocal of -3/5. The negative reciprocal would be 5/3. So I'm starting with that as my slope. And then I'm going to plug in my point 0, 2 for x and y. This term drops out because it goes to 0. So I get that b equals 2. And my final equation would be y equals 5/3 plus 2. And we're going to try this more in class with the Mathletics tomorrow. So keep practicing on your own, and we will practice together in class. And until then, have a good night.